Hi everyone, it's Miss Costa here, and in this video we're going to be looking at how to solve one-step equations. Okay, so here we've got a set of examples and we're being asked to solve these equations to find the value of x. Now when we're being asked to solve an equation, what we're being asked to do is to work out what the missing value is. And when it comes to equations, it helps to think of them as balanced scales. So if we think about it like this, we've got x plus 5, so it's the weight of an object. We don't know how much it weighs, but when we put it on a set of scales, we know that it weighs exactly the same amount as 30 kilograms. Okay, so x plus 5 kilograms, the weight of our object, plus 5 gives me 30. So when we consider equations, it's helpful to just remember they're like balanced scales. So one side must equal the other. Now, if we were to try and figure out what the value of x is, over here, I might say, okay, well, if I took away these 5 kilograms, so essentially what I've done is I've just taken away 5, the scales are going to tip. So what I need to do is do exactly the same to the other side over here. So I've taken away 5 kilograms from both sides, and by doing that, by subtracting that 5 kilograms, I figured out what x must be. So I can apply this back to my equation. Whenever I am trying to figure out what x is, I need to always be keeping the equations balanced, and in order to do that, whatever I do to one side, I have to do to the other, and to move anything so that it cancels itself out. So that was 5 kilograms, and I subtracted 5 kilograms so that I'd be left with 0. I must do the inverse operation. Now, just a quick recap, if we may have forgotten, the inverse of addition is subtraction, and the inverse of subtraction is addition. Positive 5, take 5, cancels itself out, so I'm just left with 0. But whatever I do to one side, I have to do to the other, so that becomes 30, take 5, which gives me 25, and I drop my pen. So x must be 25, and that's it. You've solved the equation. So x equals 25. That's all you have to do. Okay, let's try the next one. It's a little bit more difficult to represent this on a scale because negative numbers are difficult to represent visually. But if I apply the same logic to move anything from one side of the equation to the other, I have to do the inverse. Now, the inverse of subtraction is addition. So I add 7 to both sides because minus 7 plus 7 takes me back to 0. It cancels out. And 30 plus 7 gives me 37. So I'd be left with x equals 37. Once I've got x on its own, I've solved it. That's all solving equations means. It means get your variable on its own on one side of the equation so you can figure out its value. Okay, so hopefully those two seem quite straightforward. Now I'm going to give you an example of a trickier one, and if this is too tricky, don't worry because it's negatives that you need to focus on and you've grasped what solving equations is. So don't worry, but just watch this example. So what do I do to move anything from one side of the equation to the other? I need to do the inverse. I've got my x, it's a negative x because the sign always belongs to the term after it. So I'm going to want to move this so that I can get x on its own. So the inverse of a negative 9 is plus 9. So I add 9 to both sides because minus 9 plus 9 gives me 0. So I'd be left with minus x equals 12 plus 9 is 23. And now what do I have to do? This is where it gets a bit tricky. I have isolated x, but it's a negative, and you never want to leave your answer as a negative x. So what I can do is multiply both sides by negative 1. Now, if you've forgotten or you didn't know, when you multiply a negative by a negative, your answer always becomes positive. So by multiplying negative x, and negative 1x means negative x means negative 1x times by negative 1, that would give you positive x because negative 1 times the negative 1 gives you a positive. Once again, if this is taking it too far, don't worry, just an example so that you can see what you might need to do. So if you've multiplied both sides by -1, you get x equals -23, okay? And that's how you've solved this one. But really, the focus of this video is feeling confident in doing these 2 steps. So let's see if we can have a go with the practice questions. So here are those examples again. If you want to copy them down, just press pause. And now it's time for you to see if you can put into action what you've just learned. And here are the answers. Hopefully you've got these all right. If not, just drop a comment below and I'll see if I can help you out. We've got some different examples. So once again, equations are still like balanced scales, except here I've been given ones where I'm going to have to use multiplication and division. Now, just as a quick recap, if you may have forgotten, when I've got a number and a letter next to each other in algebra, so 2x, what that actually means is 2 times by x. Okay, in algebra we don't write multiplication, it's just implied if something is next to each other. It's like invisible algebraic multiplication glue. Okay, so here, what does this mean? X is being multiplied by 2 and the result is 6. And I can show it, represent it on this scale. 2x, so 2 lots of x, is equivalent to 6, let's say 6 kilograms, okay? Now, I've got 2 lots of x, so I want to figure out what 1 lot might be. So what I could do is half it, divide it by 2, okay? So if I half this side, if I divide this side by 2, I'm going to have to do exactly the same to the other side. So get rid of half of what is on this side. And by doing that, I can figure out what 1 single x must be. So x must be 3 kilograms. The way we can write it by showing our algebraic working out is I know 2x means 2 times by x. So I have to do the inverse. Now the inverse of multiplying is dividing, and the inverse of dividing is multiplying. So 2 divided by 2, that cancels out to give me 1. And that's why I'm left with just x on this side. Now, whatever I do to one side of the scale, I have to do to the other so that I keep them balanced. So 6 divided by 2 gives me 3. Okay, let's try that again. So 5x equals 30. 5 times by x is 30. What do? I want to get x on its own, so I have to get rid of this times by 5. To get rid of anything, or to move it from one side of the equation to the other, I do the inverse so that it cancels out. So 5 divided by 5 is 1, so I'm just left with x, and 30 divided by 5 is 6, so x is 6. And now this kind of question does sometimes confuse people because it's in a fraction. But what does this line here mean in a fraction? All that means is divide. So it's another way of just writing division. So we could write it like this. X divided by 2 is 14. But hopefully you're going to become familiar with this format because that's how we write division in algebra. So that just means divide. I want to figure out what my x is. I know something divided by 2 gives me 14. So I have to do the inverse. The inverse of dividing by 2 is timesing by 2. So that cancels out to just leave me with x. And 14 times 2 is 28. Okay, so once again, let's have a go at these and see how we get on. The key thing to remember is when we're solving, we're trying to figure out the missing value. Okay, so you might want to start by putting your finger on it and just thinking what else is left over on this equation, what's happening, and how can I get rid of it so that I get x on its own. Once you've got x on its own, you have solved the equation. Okay, so solve just means get x or a or z, whatever the variable is, on its own. And once again, here are the examples if you want to write them out. And now let's have a go at trying these out for ourselves. Remember to press pause so that you can work these out. And here are the answers. If you found this video helpful, then remember to like and subscribe and let me know if you have any other topics you'd like me to do.